Welcome back my dear friends and dear students, a very good morning, good afternoon, good evening to all of you wherever you are. And this is the DADM2, which is Data Analysis and Decision Making 2 course under the NPTEL MOOC series. And as you know, this was total course is basically for 12 weeks, which is 30 hours of contact over the lecture series, and which is 60 lectures in total, because each lecture is for half an hour, and we have already completed 11 weeks, each week with 7 lectures, and after each week you had assignments. And if you can see the number here, it is the 60, DMDM2 lecture number 60, which is the 12th week. That means we are going to wrap up this course with this lecture. And obviously after this lecture you will basically take assignment number 12, and with that you will basically have the final examination also, which covers the whole course. If you remember, we were discussing about the concept of ANN very briefly, then we went to the concept of change point detection also briefly, and we just mentioned the type of tests. So, Petit test would be utilized considering the concept that we want to basically check the points under the Mann-Whitney concept of test, which we will consider, where we are using two things. I will just give a very brief 2-minute discussion, which I actually do before the starting of the class. So, you have the ANN methods will be utilized, because prediction of exchange rate is a non-parametric method, because we do not know which parameters based on which you can predict the exchange rate. And as I said, there can be different parameters which change, and what is the fluctuation also we do not know. It can be petroleum price, gold price, silver price, it can be inflation rate, it can be interest rate of that country, it can be interest rate of other countries, whatever it is. What is the GDP, GNP, population? There can be many objective and subjective criteria. Say for example, suddenly there is a political upheaval in one country, so obviously it will have an effect on the exchange rate. Consider this an election. Now we basically would try to predict using the artificial neural network. The prices are there, we would like to predict, but the actual prediction is not the main concern. Our main concern is to find out the change point depending on where we can take a decision whether you want to enter the exchange rate market or come out of that. Added to that, we will try to basically fine tune our ANN network based on this, either the conjugate gradient concept method, and to top it all we will basically utilize the ANN and ANN along with the conjugate one with genetic algorithm simulated annealing, and we will try to utilize this combination for two sets. One is the change point detection algorithm being utilized, and another case the change point algorithm not being utilized. Obviously, when you run any method or tests, you have some criteria based on which you want to basically analyze how good or bad your results are. Like, so if some of the results I will just briefly mention them, is the mean square error, where we try to predict the actual value, difference of the actual value and the predicted value, and find out the square of that and find out the average. So, this is something to do with trying to minimize that mean square error, is something to do with minimizing the variance, because there is a square term and you are trying to find out the average. The mean absolute error is that we find out the errors in any direction and try to basically give the weightages of plus. So, that means any negative or positive in direction methods are considered positive, then again we find out the expected value. The direction accuracy one is basically that depending on the actual value and the predicted value for the time period next I plus 1, whether if it is both are positive you give a point of 1, and if both are negative also you give a point of 1. So, in the direction that the predictions is which is happening, the actual value now and the predicted value later on, and the actual value later on. So, if the difference between the actual value then, that means t plus 1 and t, and difference between the predicted value of t plus 1 and the actual value of t, if they are moving in the same direction, that means we are trying to predict in the right direction. If it is more positive, The first one is positive. First one means the difference between yt plus 1 and yt, and the second difference between yt plus 1 hat and yt. If both are positive, then it is plus 1. Both are negative, that means I am going in the negative direction, my prediction is also right, then also it is positive. If they are in opposite direction, that means actually it is going plus, it is increasing and I am giving a prediction on decreasing, or vice versa, then obviously the A value would be negative. We will try to basically find out the direction accuracy on an average. The Pearson correlation coefficient and Thiel's coefficient of inequality would be utilized depending. Pearson correlation coefficient we know is basically very simply the correlation coefficient which we use in the concept of covariances, and the Thiel's coefficient inequality would be the root mean square error divided by the prediction value which is happening for 2 time periods, n minus 1 depending on the value of the degrees of freedom which we already have considered. So, now we basically take the US dollar to Indian rupees and US dollar to UK pound, the exchange rates, and they are taken from 2000 to 2009, from 1st January to 17th of February, and here you see the exchange rate of US to Indian spot rate. So, say for example, you may say, well, pictorially I think there is a change point here, or there is a change point here, or is the change point here, maybe a change point here, maybe a change point here. So, this total time frame is capital T, and we will basically try to find out if this is tau 1, this is tau 2, this is tau 3, this is tau 4, and so on and so forth. So, pictorial what you are seeing we will try to basically verify it using the ANN, added to that the conjugate gradient method plus the genetic algorithm and the simulated annealing method. So, we find out using the time series concept, the lags and the autocorrelation. So, the subgroups are based on the fact. So, we have basically the data set of 2383 data points. So, we have the subgroups from 1 to 595 data point, 596 to 1192, 1193 to 1788, this should be 1189. So, 1189 to 2383, based on that the subgroups are calculated, and we find out the autocorrelated values of the US to the Indian spot rate for the source 4 subgroups based on which you can divide and then proceed. Subgroups, you remember I mentioned that if you want to predict standing from rodeo 1 year down the line, there would be time points in between where we want to enter the market or come out of the market and take a decision accordingly. So, those sub points or subgroups where the data change point is happening, we want to check that. That is why we are divided into subgroups. The configuration of the various models is shown below. For the US Indian exchange rate, so the number of hidden layers for the OK. Now, remember we had mentioned that the model which we will try to use, obviously we do some learning methods. Learning means we find out the optimum number of nodes and the hidden layers. So, the number of hidden nodes which is there for the neural network in the conjugate gradient method is 6. The nodes configuration for the genetic algorithm being utilized with conjugate gradient method, I am not considering them singly, I am basically singly in the sense not ANN using the genetic algorithm or ANN using simulated annealing. So, the nodes are basically 11 cross 10 into 6 and 9 cross 12 into 8. So, the summary of these results are as follows. So, this learning of how the nodes are built up, I skip that and come to the results accurately. So, this is the spot exchange rate depending on from 2000 to 2009, which we have already considered. Now, the metric for comparison for these using the neural network conjugate gradient method, genetic algorithm, simulated annealing, genetic algorithm and conjugate gradient method and simulated annealing using conjugate gradient method. All the statistics are given. Statistics means the metric based on which we are going to say how good or bad our predictions are. We use the mean squared, the mean absolute error, the direction accuracy, the Pearson coefficient and the Thiel's inequality coefficient. So, the values come out of this. For the mean square it is 10 to the minus 2, 7. this is 8 into 10 to the 7 into 10 to the minus 3, sorry, this is 8 into 10 to the minus 2, this is direct accuracy is 7 into 10 to the minus 1, Pearson coefficient is about 1 and Thiel's inequality coefficient is about 1 into 10 to the minus 3. So, all the values basically are given depending on the performance of the 5 models. Now, here if you remember that the points which are marked arbitrarily, now when I do the change point detection depending on the Petit test, and when I find out the change points for the US and the Indian rupees are happening like this. So, I have not marked at exactly what point. So, the change point is happening round about 600 data point. Another is happening, say for example, 3 points are happening between 1000 to 1500, one is happening say for example at the range of 1700 and another one is happening at the range of about 2000. So, in all from 2000 to 2009, if I take the data point, so that the number of change points is basically 1, 2, 3, 4, 5, 6. Even though it looks that a lot of data points change point is happening, but here we predict the change point is 6 in number. Now, performance of the metric based on the change. So, initially the change point was not utilized algorithm, now you use the change point, and the mean square, the absolute mean square errors, the detection accuracy, Pearson coefficient values are given. I am not going to the details of the discussion on the values. Now, I want to basically give the summary of the mean square errors. So, I have grouped them into 2 groups. One is without change point detection algorithm, one is with change point detection algorithm. But here we will basically have the without the change point detection algorithm, which is happening is conjugate gradient method, genetic algorithm, simultaneous annealing, and then utilizing conjugate CGM, conjugate gradient method along with SA, and conjugate gradient method along with GA. Similarly, when I use the change point, again the same sequence, we use neural network with change point detection and conjugate gradient method, then genetic algorithm with change point detection, simultaneous annealing with change point detection, and finally the neural network which considers change point, gradient method, genetic algorithm, and the last one being change point, gradient method and simultaneous annealing. So, the errors would basically give me which is the best. If you check generally, so they are very low on the scale of mean square error. So, the best which is coming out to be, if I consider through the pictorial one, is the generic algorithm being used with change point gradient method without change point and the conjugate gradient method. Another one, the best one is coming out to be the conjugate gradient method along with generic algorithm and the change point one. So, the error is the best here, error in the least sense. So, results for the ARMA-GARCH model, if we use the mean square. So, we can compare these results along with the results which we get for the different combinations of the change point and not change point method being utilized in the ANN along with GR or an SA. Okay. Now, I have just given a snapshot of the discussions which we had. So, I will try to wrap up this DADM 2. So, I will go through. So, if I consider, I will go very briefly. So, this is the set of slides which we have discussed. So, the first one what we discussed was basically the concept of utility theory. So, in utility theory, utility analysis, we did the concept of different type of absolute utility concept, the relative utility concept and the absolute utility concept being utilized. Then we found out or tried to discuss the concept of non-satiation and the risk aversion properties. Then we considered the 4 different types of utility function, quadratic, power, then the concept of exponential utility function, logarithmic utility function. Then we discussed different examples. Then we went to the very simple concept of how we can find out the safety first principle can be utilized where you want to maximize or minimize the functional form. And then we consider the expected utility, obviously you can find out, and then we considered the concept of rather than discussing through the slides, I am just mentioning what we have covered. Then we consider the safety first principle, which I did repeat. So, they were different. Then we consider the geometric method and comparison the geometric method with the generally the safety first principle, and I did also mention that using the quadratic utility function also means that the returns was normal and vice versa. So, this is the two way implications for that. So, then I will close and open the slides accordingly. So, I will close this also. So, it is easier for us to discuss. So, in the next one we discuss the concept of considering the utility functions. The certainty value was important, you should definitely know that. Then we considered how you find out the certainty value and how the expected values can be found out. Then we went into the problems of certainty value and how it can be compared, how certainty value can be utilized to compressing different decisions. Then the mean variance concept along with the utility analysis was done. The safety first principle and the stochastic dominance concept, the geometric mean concept were discussed. Then we discussed the concepts of utility function, loss functions, then the concept of loss functions being consistent unbiasedness properties. Then we have the quadratic loss function, the mod loss function with unequal penalties being there for overestimation and underestimation both for the linear part and the nonlinear part also. Then we consider the Linux loss function where overestimation and underestimations can be prioritized, and I give you 3 examples. Then we considered very briefly the balance loss function, which was considered a part and parcel of a multiple linear regression and how it can be utilized. Then we consider the data envelopment analysis. In data envelopment analysis, we consider that what is input bundle, output bundle, what is the decision making unit, and how increasing, decreasing and constant return to skills. We will have 3 different diagrams based on which you can find out the maximization and minimization of the problem, which can be converted into linear form. And then we covered the concepts. This is, I think this is the DA part. I will try to. So, this is the DA part we already considered. So, this is no need of repeating it. So, this went on for quite long. Long means the number of lectures. So, they are basically being saved and given a concept based on the lectures. Then we consider the concept of decision trees. This was where we considered the probability of success, failure, then for the drills and how you can utilize the concept of expected value, variance to rank the decisions. If both are to be considered, how you can take the ratio of the expected value to variance and rank them from the highest to the lowest, or you want to take the ratio of variance to the expected value, rank them from the lowest to the highest. So, we did consider examples accordingly, and I did mention that considering that utility values are negative, we will definitely take some of the problems where utility values will be considered 0 in order to compare the models, even though negative values are possible. Then we consider the concept of AHP, analytical hierarchy process, and how the hierarchies are there, how the probabilities could be multiplied, and how you can utilize the concept of eigenvalues, eigenvectors to find out the ranking, consistency ratio, consistency ranking, and based on that how you can basically rank the decision process. I gave you examples that if you are trying to buy a house or buy a car, there are objective and subjective values also, and in ANN you should basically consider, and analytical hierarchy process, you should consider the weights to be in such a way that they can be in a scale of 1 to 9 with odd numbers, or they can be in the even numbers also. So, highest value being the liking and disliking being such that if A1 is compared to A2, these are the alternatives, and if A1 gets a point of 9, so A2 would basically get a point of 1 by 9, that means I dislike it, and based on that you basically multiply those values in order to get the ranking system. Then if I go to then for the 6th, these numbers which are given are the weak number. So, then we went into the Electra method, and Electra method we will only consider one of the methods. Then we considered the concept of the in Electra, epsilon Electra also, where the liking disliking in the inference sets were there. In the initial method or Electra method, you have the concordance and discordance sets, liking and disliking, and club them in the sets and basically rank them and found out the values. In the epsilon Electra values, we basically had the, again as I mentioned few seconds back, liking disliking in the indifference sets, such that together basically they constitute the whole universal set, and based on that we can do the ranking. And you can find out the liking set, disliking set and the indifference set, based on which we can compare whether alternative A1 is better than A2 or A2 is better than A3. And you remember that when you are trying to basically combine this concordance, discordance and the indifference set, we are trying to take all the criteria into consideration, such that collectively they would give a overall decision based on all the criteria when we are comparing alternatives with respect to each other. And obviously, here how you do the normalization is important depending on the utility function. Normalization, if you remember, I did mention time and again, if normalization you are doing along the row or along the column, remember to check the values is 1, because if you consistently follow the row 1 or the column 1, do that accordingly for all steps. Point 1. Point number 2, I also mentioned that if you are trying to change the utility function in between, that would not be possible technically when you are solving the problem, because different people may have different utility functions as the age, as the income changes, as the risk preference changes, but we are not going to consider that in our analysis of the problem. Then late in the 7th week set of lectures, we consider the concept of Topsis method. In the Topsis method, it was basically the center of distance of the liking and the disliking, how far it is from the liking point, median point, which is the liking set and the disliking set. Based on that, again we differentiated. Again I mentioned the concept of utility function. Again I mentioned about having a weighted matrix which could be normalized. Based on that, we can multiply the priority values or the values which are assigned for each decision, each alternatives, and then rank them accordingly. In the 8th week of lecture, we consider the Weicker method. Again the Weicker method is exactly similar to the Electra and the Topsis method, but the algorithm based on which you will basically rank them would be different, and I did discuss one of the algorithms in details in one of the methods. Based on that, you can build up the models everywhere. And I also discussed the difference between this multi-criteria decision making Weicker and Topsis, how the vector normalization could be done and how they can be utilized. Then in the 9th week lecture, we considered MAUT and MAUT, the multi-attribute utility theory and multi-attribute, the utilities being considered, where utilities could be added or depending on the functional form, and I did here there were no problems, it was just a general concept. In the 10th week, it was more to do with the concept of robust optimization, reliability, and how the concept of utilities could be utilized, or the concept of multi-criteria decision making can be utilized from the objective function. It was more of a very conceptual idea where problems can be solved, but trying to basically develop the problem, you have to basically write the code. I did mention that I am not going to go into the detail of the solution method, it will be considered in the DADM 3. And then we considered in the 11th lecture, we considered the different concept of GERT method, the general evaluation review technique and QGERT method, and we considered the concept of OR network, AND network, and how they can be combined to come with the different scenarios. Here looping was allowed, where PERT and CPM do not consider looping. And in the 12th lecture, we considered the artificial immune system, the ANN method, and tried to combine, give a example in area of finance, very simple area of finance, where bankruptcy prediction was important, and you can achieve better results using AIS. And in the artificial neural network, we considered the prediction and of the change point in foreign currency exchange, considering two different heuristic methods with genetic algorithm and simultaneously. With this, I will like to say thank you all for all your attention and the amount of energy and the time you have spent for doing this course. If you have any queries, you are most welcome to write it to the tutors, and if personally you think you want to further your knowledge in this field, you can definitely write to my email ID. You can check the net and basically find my email ID and write to me. I generally would definitely reply with all the details as may be required. Have a good day and best of luck for your future. Thank you very much.